capturing all of this data because it's not being sent over HTTPS anymore. It's being sent over HTTP. And if you look in here, you can see we captured login information. It's sent to linkedin.com, sent to this specific URL, a login URL. And you can see the username is zaid@zsecurity.org. And the password is 123 all the way up to 90. So that's really, really good. Let's go ahead and test another HTTPS website. Let's go to stackoverflow.com. Again, you can see on top, it's loading over HTTP, not HTTPS. So I'm going to click on login. And again, I'm going to put my email, zaid@zsecurity.org, and we'll put a password as 12345678990. Hit enter. And let's go to the Kali machine again. Scroll down this time because we're stuck on top. And perfect. You can see we have a post request in here. It's sent to this specific URL. Again, you can see login in the URL. You can see the website itself, stackoverflow.com. And if we scroll down a little bit more, we can see that the username is zaid@zsecurity.org. And the password, again, 123 all the way up to 90. So that is really, really good. Now we can downgrade any HTTPS connection to HTTP as long as the target website uses HTTPS, not HSTS. So this method will work against pretty much all websites that use HTTPS, except for the really popular websites such as Facebook, Twitter, and so on. So let me show you a quick example. If I go here and try to go to facebook.com, you'll see that the website got loaded over HTTPS, not over HTTP, even though we configured our couplet correctly, and even though we're able to downgrade HTTPS connections on a lot of websites such as LinkedIn and Stack Overflow. This is happening because Facebook is using HSTS, which is a little bit trickier to bypass. In the next lecture, we'll talk more about what HSTS is, why it's tricky to bypass, and how to partially bypass it and still get usernames and passwords from the websites that implement it, such as Facebook, Twitter, and so on.
Như vậy là chúng ta xem đoạn video đấy là cái the cap vừa rồi ấy, thì nó có cái caplet mà nó chuyển những cái domain ví dụ như là LinkedIn đúng không? Hay là cái trang web vừa rồi là nó có phiên bản là HTTPS và phiên bản HTTP thì nó tự động nó sẽ downgrade cái giao thức HTTPS về HTTP để người dùng sử dụng cái phiên bản HTTP mà không biết. Có thể họ không lưu ý là trên cái trình duyệt này nó không có cái khóa này hoặc là nó không có chữ skill thì chúng ta hiểu là nó không có mã hóa, phiên bản không mã hóa. Tuy nhiên thì cái cách làm như vậy nó sẽ đánh lừa được một số cái trang web, nhưng mà một số trang web mà sử dụng HSTS thì nó lại không thành công, bởi vì những cái trang web này, cái trang như trong Facebook ấy, thì nó có cái cơ chế bảo vệ dựa trên cái giao thức gọi là HSTS, nó tự động kiểm tra xem là cái phiên bản có phải là phiên bản HTTPS không, và nó tự động chuyển về cái HTTPS nếu mà người dùng cố tình đăng nhập vào phiên bản HTTP. Thế thì cái video tiếp theo chúng ta sẽ xem là cách mà tác giả trình bày hacker.
In the previous lecture, we seen how
nó làm sao để vượt qua cái giao thức HTTPS. Cái này nó là một cái trick, một cái mẹo Tuy nhiên tất nhiên là vẫn có xác suất là không thành công, không phải là thành công hoàn toàn.
To downgrade HTTPS websites to HTTP, and this allowed us to basically see anything a user does on these websites because data in HTTP is sent in plain text. Therefore, we were able to see the usernames, the passwords, the URLs, and anything they do on HTTPS websites. At the end of the lecture, I also showed you that the method will not work against Facebook, Twitter, and other websites that use HSTS. The reason why it won't work against these websites because modern web browsers come with a list of websites that they should only load over HTTPS. See, what we were doing
Các bạn thấy đây là cái viết tắt của chữ HSTS này, HSTS tức là HTTP Strict Transport Security, tức là nó sẽ ép buộc cái phiên bản mã hóa của HTTP được sử dụng thay vì HTTP thuần. Thì viết tắt là HSTS là HSTS này, và nó được sử dụng bởi những cái trang như Facebook, Twitter và những cái trang web nổi tiếng khác. Nó ép buộc là sử dụng cái phiên bản mã hóa của HTTP.
over HTTPS. See, what we were doing in the previous lecture, whenever a browser requests a website, we load that website even if it uses HTTPS, but we always give him back the HTTP version. In HSTS, the browser knows that this website, for example, facebook.com, should always be loaded over HTTPS. So even before sending this request to us, it'll always send it in HTTPS, and it'll always only accept it if it comes back as HTTPS. So there's nothing we can do really once we become the man in the middle, because the browser is doing this check locally. It's checking this against a list that is stored on the computer itself. Therefore, the only practical solution at the moment to bypass HSTS is to make the browser think that it is loading another website. To do this, we're going to replace all HSTS links in loaded pages to similar links, but they're not the same links. For example, we can replace facebook.com with facebook.corn. Now, I know this seems very suspicious, but trust me, when it goes into the URL bar, the RN here at the middle, it'll seem very similar to the M letter. Another way of doing this, you can replace twitter.com with twitter.com, but with a single T here instead of a double T. I know this sounds a little bit confusing right now, but let me go and do it practically and you will see how this is gonna work. So right here I have my Kali machine, and we're actually gonna use the HSTS couplet that we used in the previous lecture. So I've already showed you where to download it and where to place it. Please make sure you use the couplet that I gave you in the resources of this lecture, not the one that comes with better cap, because the one that I gave you in the resources of this lecture is modified and it contains code that will actually replace the domain names as shown in here. The original one does not contain that code, so it won't work as I'm gonna show you right now. So, as shown in the previous lecture, I already have my caplet in here, in user share, better cap caplets, and this is the name of the caplet. If we go inside it, we have a file called hstshijack.cap. This is the configuration file of the caplet. So I'm gonna right click it. I'm going to open it with other application. I'm going to click on view all applications, and you want to pick any text editor that you have. So I'm going to keep this at LeafPad. You might have to scroll down to find it, but I have it here. I'm going to select. And as you can see, we have a normal text file with all the configurations that we can set. And I've already pre-configured this for you. The main things that you want to understand and maybe change is the targets and the replacements. So the targets are the domains that use HSTS that you want to replace. For example, I have twitter.com in here. And I also have star.twitter.com. Basically, when you use a star, this is a wildcard, and it basically means any subdomain .twitter.com is a target as well. In the replacement, you want to tell the program what to replace this target with. For example, whenever we see twitter.com, we're going to replace it with twitter.corn. Similar goes for Facebook and Apple and a few other domains that I set. You can also play around with the obfuscate and encode options. I've set both of these to false because basically what these will do, they'll obfuscate the code and encode it. But I noticed some browsers like Firefox will block obfuscated or encoded code. That's why I set both of these to false so that the code is left as is. Here in the payloads, you can set any other JavaScript code that you want to inject. Leave this the same. We'll talk about JavaScript injection in a future lecture. Finally, you want to make sure that the DNS spoof domains are set exactly the same as the replacements in here. So I literally copy this line and paste it here. Now I'm actually going to keep all of this the same. I don't need to modify any of it. But like I said, if you're targeting different websites or if you want to use different replacements, for example, if you wanted to use a Twitter with a single T and keep this .com, you can do that here. If you wanted to use a Facebook with a single O and keep this .com again instead of .corn, you can do it here. Once done, make sure you save and quit this file. And we're ready to run the attack. So running this attack is actually going to be identical to what we did in the previous lecture. You just want to make sure you modify this file properly. So going back to BetterCap, I'm going to clear the screen, run BetterCap with the same command, loading the spoof caplet so we can do all of the ARP spoofing commands and run the sniffer all automatically. And perfect, as you can see, everything is running as expected with no errors. If you run this and you get an error, just do exit and run BetterCap again. Next, we want to run the caplet, the HSTS hijack caplet, exactly as shown in the previous lecture. All we have to do is type HS tab, it'll autocomplete for us, and hit enter to run it. Again, as you can see, no errors, so everything is working as expected. Let's go to the target machine and see how this is going to work. So I have my Windows machine right here. This is Chrome, the latest version in April 2019. And before I do anything, like I said, it's a good idea to always just remove the browsing data. And before I actually load any websites, it is very important to understand that even with everything that we're doing right now, if you try to go to Facebook and type .com at the end here, it will not work. What we're doing right now will not work because Chrome right here has a list that is stored on this computer that says do not load facebook.com unless it is loaded over HTTPS. So if you type Facebook right here like this, it will not work. The only way we can do this is if the user first goes to a search engine, for example, google.ie for Ireland. And then in Google, as you can see, Google doesn't use HSTS. So we bypass this using the normal HTTPS bypass. And then if the user in here searches for their target website, for example, Facebook, then our script is going to run in the background and it's going to replace all links in this page for facebook.com with facebook.corn. So if I actually hover over this, you'll see in the status bar, the website that will be loaded is facebook.corn, not facebook.com. This is fine here. It still says facebook.com, but only in the code of the HTML page, facebook.com got replaced with facebook.corn. So if I click on this link, again, as you can see, we get a normal Facebook page, but if you look here on top, you'll see there is no HTTPS. And if you look at the domain name, you'll see it says .corn, not .com. Again, like I said, you can actually keep this .com and use Facebook with one O, or you can add an extra O. You can be as creative as you want with this. This is just an example that I'm giving you. Now, if you did not get this, if you got an error page with a dial TCP error like this one, then please have a look on the video in the resources of this lecture. It will show you exactly how to fix this issue. Now, once we're here, we can log in normally with my username, so zaid@zsecurity.org, and put my password 1234567890. Hit enter, and if we go back, scroll up. Perfect. As you can see, we have the username zaid@zsecurity.org and the password all the way up to 90. Now, like I said, the only way for this to work is if the user gets to Facebook through another website that does not use HSTS. If they go on the URL bar and type facebook.com themselves, we will not be able to do this. That's why this is considered as a partial solution and not a full solution.
Các bạn thấy là cái trình duyệt của chúng ta dùng như là Chrome ấy, thì nó đã hard code cái trang web như là Facebook hay Twitter, cho nên là khi chúng ta có facebook.com hay là twitter.com thì nó tự động sử dụng cái phiên bản HTTPS và nó có sẵn ở trong cái code của nó rồi, hard code thì chúng ta không thể làm gì được. Cho nên là cái phương pháp vừa rồi mà gọi là một cái mẹo, một cái trick, thì nó thay thế những cái tên miền facebook.com hay là twitter.com bằng cái tên miền nó hơi gần giống như vậy, nhưng mà nó chỉ có tác dụng khi mà cái người dùng vào bằng những cái cách như là search và Google, chứ không phải là vào cái địa chỉ trực tiếp của trang web đó trên trình duyệt thành địa chỉ để mà có facebook.com thì nó hard code rồi, cho nên không thành công được. Còn nếu mà search bằng Google thì bởi bản thân Google nó không phải HTTPS, nó không HTTPS trên Google, cho nên là nó có thể thay thế cái URL của nó được, và chúng ta có cái tên miền như vừa rồi là facebook.com nhưng mà .com thì người dùng lúc đó sẽ sang cái phiên bản mà nó không mã hóa của Facebook. Bây giờ nó sang DNS spoofing.
Now in this lecture, we're going to learn what DNS
mà đánh lừa chúng ta đã nói ở trong cái phần hôm trước là về cái việc giả mạo tên miền, đúng không? Thì mai tôi sẽ xem cái video về cái phần này.
DNS spoofing is and how to perform it. DNS is a server that converts domain names such as google.com to the IP of the server that is hosting this website. So when you type google.com in your web browser, the request goes to a DNS server. The server responds with the IP where google.com files are stored, and the browser will load the website from this IP. Now, when we are the man in the middle, the request for google.com will pass to us first before it goes to the DNS server. Therefore, instead of giving the IP of the server that is hosting google.com, we can actually give any IP we want. So we can redirect them to a fake website with a backdoor or with evil code, hijack software updates, and so much more. We'll actually have examples on this in future lectures, but for now, let's see how we can run a basic DNS spoofing attack in which we redirect requests from a specific website to our own website or our own web server. Now, before we run BetterCap, let's decide on where to redirect our target to. So we can redirect them to any website we want. For example, when someone requests google.com, we can redirect them to Yahoo. But what I want to do is I want to redirect them to my own website, to a local website that I'm going to start on Kali. So Kali comes with its own web server, so we can actually use it as a website. And to do this, all we have to do is just start the web server. So we're going to do service Apache 2 start. So Apache 2 is the name of the web server, and we're saying that we want to start the service. If I hit enter, we see no errors, which means that the server is working now. And to access this website, to access this server, we have to go to Kali's IP. So as you know, to get our IP, we can do ifconfig, and we can see our IP is 10.02.15. So if I just go to a web browser and go to 10.02.15, you'll see I'll get the default page of this website. Now the pages for this default website is stored in var www html. So I'm going to open my file manager and I'm going to click here on the title bar, press / to open it, and we're going to go to var www html. And as you can see, these are the files for this website. So if you want to install a fake website or any type of website, all you have to do is just put its files in here. Now, index.html is the file that gets loaded here by default. So this is what you see in here. So I'm actually going to right click it. I'm going to open it with another application. I'm going to select my text editor, and this will open the HTML code for me. And I'm actually just going to remove this, and I'll just put a smiley face. Like I said, we're just doing this for testing, so just showing you which files get loaded by default and where you can actually put a website if you wanted to host a proper website here. So I'm going to go back here, and if I refresh the page, you can see we get the smiley face in here. Now that's perfect. Right now we still haven't executed our DNS spoofing attack, but what I want to do is when my target tries to go to a specific website, I'm going to redirect them to this page that shows this smiley face. So let's go to the target machine first, and let's go to our target website. I'm going to do this against my own website, zsecurity.org. So if you load this website, you'll see we'll get an actual security website with a number of topics and all that kind of stuff. Basically, the website is working as expected. Now, let's go ahead and run this attack. So I'm going to go to BetterCap. I'm going to run it using the exact same command that we've been using so far. So we're just doing BetterCap with the interface, with the spoof caplet, so we can intercept data and modify it as it's flowing through our computer. And as you can see, it's running with no errors, so that's all good. Now, the module that we want to use is, so if I do help, you can see it right here. It's called DNS spoof, and it's not running. And as usual, if we don't know how to use a module, all we have to do is do help, followed by the module name, and in this case, it's DNS spoof. And as you can see, we get all the options that we can set for this module. First option being the DNS spoof address. This is the address that the user will be redirected to. So if you want to redirect them to another website, you have to put the IP of this other website here. In my case, I want to redirect them to my local website, to the website that we have here, which is running at 10.02.15. Therefore, I'm not going to have to modify this because by default, this is set to the IP of my interface. The next thing that we want to modify is the dns.spoof.all. We want to set this to true so that BetterCap responds to any DNS request. So, just like any other option within BetterCap, to change its value, we have to do set, followed by the option name that we want to modify, and in this case, it's dns.spoof.all. And we want to set this to true. Sorry, this is all being produced by the sniffer. The next option that we want to set is the dns.spoof.domains. This will specify the domains that we want to target, that we want to spoof. And as mentioned, we can use a comma to separate more than one domain. And as you know, we want to target zsecurity.org and we want to redirect that to our own website running on Kali. So we need to change this option right here, dns.spoof.domains. And again, we're going to do this by doing set, the option name, which is dns.spoof.domains. And we're going to set this to zsecurity.org. As mentioned in the option, we can use the comma to specify more than one domain, and the other domain that I want to specify is star.zsecurity.org. So the star right here is a wildcard, and it basically means that I want to target any subdomain .zsecurity.org. So I'm going to hit enter and we don't see any errors. So everything is set as expected. And all we need to do now is start the DNS spoof. And to do this, we just need to run dns.spoof on exactly the same way that we start any other module. I'm going to hit enter. And this should be running right now. And as you can see, it's telling us that it's going to spoof zsecurity.org to this IP, which is again, this is our IP. We verified this using the ifconfig command. And keep in mind, we actually did not have to give BetterCap this IP. It got it automatically. It's also telling us that the other target is star.zsecurity.org and it'll be spoofed to this. Now, let's go to the target machine and test this. And before you test this, please keep in mind, you might need to wait for a minute or two for the changes to propagate. Also, if you just loaded this website, just like I did right now, it's a good idea to remove all your browsing data. You won't have to do this in real life scenarios, unless the target person is constantly loading the same page, which doesn't happen a lot. But if the target person goes ahead and browses a few websites, comes back to zsecurity.org, and perfect, as you can see, we got redirected to the smiley face instead of loading zsecurity.org. Now this will work against all websites, even if they use HTTPS. As you saw earlier, zsecurity uses HTTPS and it loaded over HTTPS by default. The only websites that this will not work against are websites that use HSTS because, again, as I mentioned before, the browser has a list of these websites. The list is stored locally on the target computer, so it doesn't send any requests, and it'll only load these websites over HTTPS. So even though the attack will work, the browser will refuse to load the website that we are spoofing them to. Now, as you can see, what we did so far is not very useful. All we did is we showed a smiley face. But DNS spoofing is very, very useful in so many scenarios. You can use it, for example, when someone is trying to go to a login page and show them a fake page. Or if they're trying to go to zsecurity, for example, and then just show them another zsecurity website with some malware embedded into it. You can also use it to serve fake updates. So whenever they have a software that's going to check for updates, we can DNS spoof that request and send them a fake update with a backdoor, and we'll see that later on in the course. So it's a really, really handy skill that can be used in so many scenarios.
Như vậy đây các bạn thấy là tác giả cho ta xem một cái cách mà sử dụng Bettercap với cái module DNS spoof để redirect sang một cái trang web mà của tác giả đã lập sẵn. Trong thực tế thì hacker có thể đánh lừa người dùng bằng cách này để người dùng đăng nhập vào những cái trang web, ví dụ như trang web ngân hàng thì nó xây dựng những cái trang web với giao diện gần giống như vậy để người dùng đăng nhập vào và bị lộ tài khoản. Thì đó là cách mà nó ăn trộm được những cái thông tin nhạy cảm của người dùng. Tuy nhiên một số cái trang nổi tiếng, trang phổ biến như là facebook.com ta vừa nói thì nó bởi vì nó dùng HTTPS cho nên là nó đã hack code rồi, cho nên là vẫn không thành công được. Nhưng mà những cái trang như ở Việt Nam chúng ta, như trang giao dịch trực tuyến ấy, thì rất có khả năng là không hack code, cho nên là rất nhiều người bị lừa vì như vậy.
So far, we saw a number of things that we can do once we become the man in the middle. So we saw how we can see anything a target computer does on the network. So we were able to see the websites, the usernames, the passwords, the images, anything they load on their browser. We also saw that since we're the man in the middle, we're able to redirect them to other websites. So whenever they request a domain, we can redirect them to somewhere else by doing a DNS spoofing attack. Another really cool thing that we can do is modify the HTML, modify the pages as they load on the target browser. Obviously, this is all possible because we are the man in the middle, because we're able to intercept all this data. So we can wait for the HTML code, which is the code that's responsible for loading web pages. And as it flows through our computer, we can insert any piece of code that we want, and the browser will execute this code. Now, HTML is only responsible for rendering the elements that you see on the web page. So it's responsible for the buttons, for the forms, for the text. It doesn't really allow us to do much. But modern browsers can execute JavaScript code. JavaScript is a powerful programming language that we can use to do so many things. We can actually modify the whole page, remove elements or add elements into the page. We can replace links, and this is actually what I did when I modified the HSTS plugin. So I added code that will replace the HTTPS with HTTP, and I also added code that will replace the actual link, the actual domain name, with the spoofed domain name, with the one with the .corn, or to whatever you set it to in the script. You can even use it to hook the browser to other browser exploitation frameworks, which we can use to further exploit the target and even gain full control over their computer. And we'll see that later on in the course. But for now, I'm going to show you how to inject a very simple JavaScript code into the loaded pages, and then we'll build up on that in future lectures and see how powerful and useful this can be. So, right here I have my Kali machine, and before I run Bettercap and show you how to inject JavaScript, first of all, we need to have some JavaScript code to inject into the target browser. So I'm going to open a text editor, and I'm going to write a very, very simple JavaScript code. Like I said, we will see how we can use this to run more useful codes, but for now, we're keeping this simple just to see how we can actually run JavaScript code. So all I'm going to do is alert, open a bracket, quotation mark, and I'm going to say JavaScript test. I'm going to close the quotation mark and close the bracket and add a semicolon. So right here, this code, all it's going to do is it's going to display a warning message, an alert message saying JavaScript code. So since we're going to try to inject this code into all pages, every time we load a web page, we should see a message saying JavaScript test. Now I'm going to save this. So I'm going to go to File, Save, and I'm going to put this in my root directory, and I'm just going to call it alert.js. I'm going to hit enter, and that is saved now in my root. So if I quit it, we can see we have the file right here. So this is the file that contains the code that we want to inject into any web page that loads on the target computer. The next step is to go to our HSTS hijack plugin. So as I showed you before, this was in user, share, better cap caplets, HSTS hijack. Make sure you use the one that I included in the resources, not the one that comes built in with BetterCap, because the built-in one will not work as you want it. So in here we have the HSTS hijack.cap file. This is the configuration file for the whole plugin. So I'm going to right click this and open it with my text editor. And in here, what we want to modify is the payloads right here. So as you can see in here, it's already injecting a JavaScript file called keylogger.js, but we also want to inject our own code. So I'm going to add a comma here, and I'm going to add star followed by a colon. We added this star right here to say that I want to inject my script into any page that the target loads. If you want to inject your code into specific domains, then you can remove the star and just list the domains that you want to inject this code in right here. But like I said, we want to inject this into all pages, so I'm going to put this as a star, and after the colon, I'm going to put the location of the JavaScript file that I want to inject into the browser. So if we look back in here, this is the file that we just created, which is in root in my home, and it's called alert.js. So I'm going to put in here, I'm just going to say /root followed by alert.js. And that's it. I'm going to save this, Control S, and quit it, Control Q, and we are ready to go. So I'm going to go to my terminal. I'm going to run BetterCap using the exact same command that we've been using. So we're just giving it the interface as ETH0, and we're giving it our spoof file to automatically run the ARP spoofing attack, putting us in the middle of the connection. And as you can see, this is working with no errors, so everything is perfect. What I also want to do right now is run my HSTS hijack plugin. And as you know, all we have to do is just type HS and tab. This will autocomplete. I'm going to hit enter, and everything is running with no errors at all. So everything is perfect. And as you can see in here, it's saying that the payloads it's loading, the JavaScript payloads, are the keylogger. This is the default one that the file already was loading, and the one that we just specified, which is in root alert.js. So now, anytime our target loads any web page, whatever code we put in the alert.js should be injected in the loaded page, and it should get executed. The result of that should show us a simple message saying test JavaScript. So let's go to the target. And as usual, a good idea is just to remove the browsing data, just to make sure that nothing is cached. And I always like to first test with the simplest case and then move on to more complex scenarios. So first of all, I'm going to test it against a normal HTTP page so that there is nothing to bypass, no encryption whatsoever. So we're just going to go to vulnweb.com. And perfect, as you can see, we have an alert message in here telling us JavaScript test. So basically this means the JavaScript code in my alert.js file got injected into this page. So now that we've verified it works against normal HTTP pages, let's go ahead and test it against a page that uses HTTPS, such as stackoverflow.com. Perfect, it's working as expected. Another example would be linkedin.com. Keep in mind, these websites use HTTPS, and as you can see, we're able to load them with no HTTPS in here, so over HTTP only. So even if you log in right here, you'll be able to get the username and the password as shown before. Finally, let's go and test it against a HSTS website using the partial HSTS bypass method that I showed you. So for that to work, we'll need to go to Google first of all, and we need to go to a Google domain that does not use HSTS, similar to google.ie. This is actually the local Google website for Ireland. And as you can see, the code works. This is fine. Google only uses HTTPS anyway. But let's look for Facebook. Now we know Facebook uses HSTS, and because HSTS is used, we should not be able to inject anything on the website because the browser will only load it over HTTPS. But using our partial bypass method, if I click on Facebook from here, as you can see, the code gets executed because what we're loading right now is facebook.corn, not facebook.com. And as you can see, we get a normal Facebook page again that looks identical, and if you log in, you'll be able to get the username and the password. So as you can see, this will work against HTTP and HTTPS pages, and even HS website, not if they put the domain name in here. So if the target comes in and literally types facebook.com manually and hit enter, the browser will force the HTTPS connection, as you can see in here, because like I said, it has a preloaded list of websites that it can only load over HTTPS. And because the browser is establishing a HTTPS connection, the data will be encrypted, and therefore we won't be able to inject anything in it.
Ở đây thì tác giả muốn chúng ta xem là ngoài việc chuyển hướng domain thì chúng ta sẽ là thể chèn thêm vào những cái đoạn mã. Ví dụ đây là một cái đoạn mã JavaScript để chạy trước khi mà cái trang web được load. Thì cái alert vừa rồi nó chỉ là một cái message. Đấy, nhưng mà thấy tôi nhận thực tế thì cái đoạn JavaScript đó có thể chứa mã độc khác mà một thực hiện ngầm ở bên dưới mà cái người dùng chi duyệt không biết được. Tất nhiên là sẽ có những cái phần mềm, ví dụ như là phần mềm mà nó sẽ kiểm soát việc truy nhập vào những trang web hoàn toàn, nhưng mà cũng không thể kiểm soát hoàn toàn hết được. Thì có rất nhiều những cái đoạn mã mà cái chương trình JavaScript ABG này nó không thể là nó kiểm soát hết được, cho nên là nó vẫn có thể có những cái mã độc thực thi trước khi mà cái trang web được mở ra.
In the previous video, we seen how we can launch Wireshark, and we said that we can actually just open a file that contains packets that we already captured, and we can start analyzing them using Wireshark. In this video, I want to start sniffing packets and then generate some traffic in my Windows machine, and then we'll see how we can analyze these packets using Wireshark. So I'm already the man in the middle. As I said, you first have to be the man in the middle to use Wireshark. And then the traffic that's generated in the Windows machine is actually flowing through ETH0, as we've seen in the previous video. So before I start capturing the packets, I want to go to the options, and I just want to show you what options we can set. So first, you can see all the interfaces that you have, and you can see the traffic generated on them. And you can see ETH0 is actually generating some traffic every now and then because it's actually coming from the Windows machine. So in here you can select the interfaces that you want to start capturing on, and you can actually select more than one interface, and all you have to do is just hold the control and then click other interfaces that you want to listen on. For example, we can just click them like this. But for now I actually only want to sniff on ETH0. Now if we go on the output, you'll see that you have an option to store these packets somewhere. So again, if you only want to sniff and you don't want to analyze things, then you can just go on the browse, and you can store the packets that you're gonna sniff somewhere, and then you can analyze them whenever you have the time at a different time. You can just open them with Wireshark like I showed you in the previous video. You can just go on File, Open, and then open the packets and start analyzing them. Now, I have ETH0 selected, and I'm just gonna click on Start. And that will start capturing packets. Anything that's going to flow through ETH0 will be captured and it will be displayed in here. Anything. I mean images, pictures, messages, cookies, anything that that computer does on the internet will flow through ETH0 and therefore will be captured by Wireshark. So it's not like Man in the Middle Life where it was only showing us the important information. Right here, you'll see anything, all the traffic that's generated. Now I want to go and generate some traffic on the target computer so we can analyze it here. But before I do that, I'm gonna go back to BetterCap and I want to start my HSTS caplet so I can downgrade HTTPS to HTTP, because if everything goes over HTTP, we won't be able to see or read anything because like I said, everything will be encrypted. So I'm gonna hit enter. This will work as expected. We'll go back to Wireshark and let's go to the target computer. I'm gonna go to google.ie and let's search for something. So for example, let's search for Z-Security. And keep in mind everything is loading over HTTP in here, so that's why we'll be able to read and analyze everything that we're loading right here. Now let's go back to Wireshark and see how we can filter this information and discover the websites visit by the target, see the requests and all that. So I'm gonna click on the stop button to stop this. This is the main interface of Wireshark, and you can see that the first thing we have is each one record of this is a packet. Now you'll see here the columns. First of all, here is the number of the packet. So you have this one is number 1, number 2, number 3, number 4. In the time, you'll see the time when this packet was captured. So 0 is when we first started sniffing, and then the time increases as we go down, and it shows when these packets were captured, when they were sent basically. You can also see the source. So this is the device that the packet was sent from. And you can see that this one is not sent from our target. It's actually coming from the internet, from a server that has this IP. And it's going to our target computer, which is 10.20.14.206. You can see the protocol. So it's TCP for this one. You can see that it's ICMP in this one. And you can see that it's ARP for this. You can see the length, which is the size. And you can also see info about this packet. Now you can also notice that these packets have different colors. Usually green is TCP packets, dark blue is DNS packets, and if we go down, we should actually be able to find some of them. And you can see all of these are DNS packets. Light blue usually is UDP, but we don't have any UDP packets at the moment. And you can also see that we have some black packets, and these are TCP packets that had a problem, that had issues. Now I know what you're thinking. There are so many packets in here, and a lot of them might not be useful to you, depending on what you're trying to get. But don't worry about this. In the next lecture, I'm going to show you how to filter these packets to only display the relevant ones, and then analyze them to extract the useful information. In this lecture, I want to spend more time with Wireshark showing you how to filter all of these packets to only display the useful packets, how to trace them, what do they mean, and how to display more information about each one of these packets. Now what we did on the target computer so far, most of the traffic that we generated was HTTP traffic. So to get rid of all this information that's hard for us to read, we're just going to type in here in the filters, we're just going to type in HTTP. Hit enter. And as you can see now, that filtered all the packets to HTTP traffic only. So this is the traffic that was basically sent by the browser and is usually sent by web browsers. They always send traffic over HTTP or HTTPS. And since we're downgrading HTTPS to HTTP, you want to use the HTTP filter to see everything that a target person is doing on the browser, regardless of what they're doing, whether they're browsing websites, whether they're watching a video, whether they're looking at images, whatever they're looking, it will be loaded over HTTP. So, looking at the first record right here, we can see that this request is sent from this IP, which is the IP of my target, to an IP on the internet. So we can see that this is not a private IP, this is an IP on the internet. So it's sent to a server. And if we double click this record, we'll get much more information about the packet itself. So we have the information about the frame, which includes the size of the packet. It includes the interface that it was sent on, the time, and all that. In the Ethernet, we have information about the source MAC address and the destination MAC address. So where did this packet go from and where did it go to? Remember when I first spoke about packets and how they always travel from a source MAC to a destination MAC? So this information is all stored in here. In the Internet Protocol, we have information about the IPs. So in the Ethernet, we had information about the MAC addresses. In the Internet Protocol, we have information about the source IP and the destination IP for this particular packet. In the transmission protocol, we have information about the port. So we can see that this went from this source port to port 80. This is usually the default port used on web servers. So in most cases, whenever data is sent to a website, it will always be sent to port 80. But the most important part in here is the hypertext transfer protocol, which is basically the data sent over HTTP. Clicking on this will give us information on whatever that has been sent over HTTP, and like I said, this would contain everything that was sent to and from a browser. So right here we can see that this particular packet sent a GET request to a website called google.ie. Now this is literally when we typed google.ie, we didn't search for anything, we didn't really do anything. You can also expand this to see more information about the actual request, and you can even see the HTTP header sent if you want to get more information about this particular request. Now this whole method of getting information follows with all types of packets, so you can double click any packet you have and you'll be able to read the data sent within this packet. Now you can also in here see an arrow, which basically means that this was a request, and the arrow back here marks that this was a response to this request right here. Now moving down, you can also see requests for images. What you can also do is click on any of these packets. For example, again, back to this GET request, right click it and go to follow HTTP stream. And this will basically follow the stream that this request has caused all the way down to the response. So if I click it, you'll see the response for this particular request was this right here. You can see that this was a PNG. And literally the binary content of this PNG image is right here. So as you can see, we're literally getting the raw data in here. Now I'm going to close this and go back to what we had, which was HTTP. Now if we keep going down, you literally see everything that has been sent and received by the target. So for example, again in here, we can see this was a JavaScript file that was loaded by Google. Then in here, we can see another GET request, and this GET request was what we searched for Z security. So you can even see the search term in here. So let me double click this to show you in more details. Again, this automatically went to the hypertext protocol part. Like I said, this is the HTTP part, whatever that gets sent to the browser. And you can see that this was sent to google.com first of all, and the URI, so whatever went after google.com, was search, and what we were searching for was that security, which is exactly what we typed in here. Again, in here, you can see the full URL with the search term. This is literally what the user gets in their URL bar in here. So as you can see, Wireshark literally shows everything that flows through the interface. In this lecture, I wanted to show you a quick overview on how we can filter data. And don't worry too much about this. We'll actually be using it more in the next lectures, and we'll see how we can easily use it to filter data and discover useful information. Now in this lecture, I want to show you how to use Wireshark to discover data sent through forms whenever someone fills up a form. And obviously this will allow us to get usernames and passwords if people log in to their accounts. So I'm already running BetterCap, so I'm already the man in the middle. And in Wireshark here, I'm just gonna start a new capture. So I'm gonna continue without saving this one. The filter is already set to HTTP, so it's only going to show me HTTP packets in here. And I'm going to go to a target website in here. So let's go to vulnweb.com. Now keep in mind, like I said, you have to be logging into a HTTP page, but that's fine because we already learned how to bypass HTTPS and even partially bypass HSTS. So I'm going to be logging into a website that just uses HTTP here because it's just simpler, and we've already learned how to bypass HTTPS and HSTS, so there's no point of repeating that. We're logging in with a username that is set to admin. I'm going to set the password to 123ABC. I'm going to click on login, and this should have been captured by Wireshark. Now let's go ahead and actually try this with a website that uses HTTPS. So let's go to stackoverflow.com. Again, as you can see, as long as the website gets downgraded to normal HTTP, then we'll be able to capture the data sent to and from this website. So we're just going to log in. Put the username, we'll put it to zaid@zsecurity.org, and then we're gonna put the password, so we'll just do 123ABC. And let's go back to Wireshark and see how we can discover the username and the password. So first of all, I'm gonna stop the capture. And what we want to look for is post requests. So you see in here, this request right here was post, for example, and here it was get. Now forms are usually sent over post, especially login forms. So if you're looking for login information, you want to look for post in here. So going down, we can see we have a post request in here. Now I'm going to click here to actually show less information so it's easier for us to see. So you can see this post was sent to Google. We're not interested in that. We're looking for
ở đây cái gói tin mà có bản tin HTTP post này nó quan trọng, người ta có thể nó quan trọng bởi vì cái post này nó sẽ gửi cái thông tin đăng nhập vào. Nhưng mà cái post này thì nó là của Google thì nó không quan trọng. Cái post mà nó thực sự gửi đến cái trang web, ví dụ vừa rồi là poolweb.com đúng không? Thì cái trang đó mới quan trọng. Cái trang mà nó gửi cái phòng đăng nhập ấy thì nó gọi mới quan trọng. Tất nhiên là quan trọng với cái người mà cần đến thông tin, còn nếu mà chúng ta không cần thấy thì nó chẳng quan trọng gì.
For stuff that was sent to VulnWeb. So I'm going to keep going. We can see we have a post request here to a login page. So this is definitely interesting. Now if we look down, let me just make this smaller. So if we look down here and look at the HTML form data, you can see that we have a username here submitted to testhtml5.vulnweb.com. The username is admin and the password is 123ABC. Now if we scroll down again looking for post requests, you can see we have a post request for a page called users login. So again, very interesting. If we click on this, you'll see, if we scroll down, you'll see we have the email zaid@zsecurity.org and the password 123ABC. Again, this just goes to show you that with Wireshark, you'll be able to capture everything. Now, this can actually be very useful because I noticed that BetterCap is great at sniffing passwords and it pretty much gets you the passwords all the time. But in the odd cases, sometimes it was failing to filter the username and the password for me. So with Wireshark, you'll actually be able to get everything that passes through your interface. So what you could actually do is you can just go to your caplet that we always use, the spoof caplet, this one right here, open it with the text editor, and as you know, in this caplet we turn on our sniffer in here, so we set the sniff.local to true and then we turn it on. But before turning it on, you can actually set the net.sniff.output to a location for a file that will contain everything that BetterCap captures. So you won't actually have to start Wireshark while BetterCap is working. You can just in here specify a place. So for example, let's say root capture file.cap, and then when you run your spoof caplet, it'll turn on the probe, turn on the recon, run your spoofing attack, putting you in the middle of the connection. It'll run the sniffer as well, and it'll store everything that BetterCap captures in a capture file. Then all you'll have to do is come here, go to File, Open, and open the file that you captured and analyze it as I'm doing right now.
Các bạn thấy là cái chuẩn file mà capture ấy, thì nó giống nhau giữa BetterCap và Wireshark, cho nên chúng ta có thể dùng Wireshark để mở lại cái file đã được capture bởi BetterCap cũng được. Chúng ta có thể analyze, phân tích nó ở trong Wireshark. Cái giao diện của Wireshark là giao diện đồ họa cửa sổ như này thì dễ nhìn hơn là BetterCap. BetterCap nó có cái hay là nó sẽ tô đỏ cái phần quan trọng, ví dụ như là cái form đăng nhập rồi những cái username password ấy, thì nó sẽ tô đỏ lên để khi mà hacker quan sát thì nó sẽ nhìn thấy dễ dàng hơn. Nhưng mà có khi là nó sẽ bỏ qua những cái nào đó, có một số trang này nó không capture được, thế phần đó không tô đậm như phần đó, trường nó rất là khó nhìn, thì khi đó chúng ta có thể dùng Wireshark để mở lại để phân tích lại.
Now, so this can be very, very useful also if you don't have a lot of resources on your computer, or if you had a small laptop or even a phone and you capture data with it. Store everything in a capture file and then just open it in here in Wireshark and analyze it. Now finally, before I finish this lecture, because all we're talking about right now is filtering data, a really useful feature when filtering data is the Control F feature, the find. So you can just press Control F from your keyboard. This will open this bar right here, the search bar, which you can use to find anything within the captured packets. So first of all, I'm gonna set the search to search within the packet details. I'm gonna keep this to narrow and wide. In here, I'm gonna set this to string so that it looks for normal text. And for example, let's say I'm looking for logins that a person named Zaid has attempted. All I have to do is just type Zaid. And if I hit enter, and as you can see, it's taking us to the login attempt when I logged in to Stack Overflow. Or let's say you're looking for login attempts by a person named admin or for a user named admin. Again, if I hit enter, it's going to take me to the first time an occurrence of the word admin happened, which is in here. It doesn't really contain any useful information, but I can just click on find to find the next packet that contained the word admin. Again, this packet doesn't really contain anything useful. We can go next. We'll actually have to go to the end of the file and go up because that was the first thing that we logged in. So I'm just going to keep clicking on next. And right here we have the post request for the admin. And if we go down again, as you can see, we have the username as admin and the password as 123ABC. So this feature can be very useful to help you find what you're looking for. Whether you're looking for a specific login name, whether you're looking for a specific tag, a specific file, and so on.
Cái tính năng tìm kiếm ở trong Wireshark thì rất hữu ích để tìm kiếm những cái thông tin mà hacker cần. giờ chúng ta nói sang cái việc hôm trước chúng ta nói về cái
Now, from the
giao thức DCP, đúng không? Mà nó có cái phần mà tạo ra những cái DCP tạo ra những cái DCP server giả mạo, đúng không? Để người dùng sẽ lấy địa chỉ từ những cái máy chủ DCP đó. Một cái ví dụ là tạo ra những exception, mà exception đó nó sẽ cung cấp cái kết nối internet trên mạng. Thì cái này nó là miễn phí, đúng không? Thì nhiều người sẽ kết nối vào. Và cái này nó cung cấp luôn cả dịch vụ DCP. Nhiều người thấy miễn phí là cứ dùng thôi, nhưng mà không biết là nó có thể đặt cái máy nghe lén, cái bộ sniffing ở đây để nó capture dữ liệu. Chúng ta xem cái ví dụ này. Cái này thì cái phụ đề hơi dở, nó là tiếng Đức, cho nên chúng ta chịu khó nghe âm thanh. Nếu bạn nào khó nghe thì thầy sẽ thích.
previous lectures, we know once we connect to a network, it's game over. Because once connected, we can run an ARP spoofing attack to redirect the flow of packets so that they go through our computer. This allows us to become the man in the middle, and once we're the man...
Cái phần vừa rồi thì tác giả chỉ đơn giản nói là cái này chúng ta đã làm rồi, đúng không? Tức là máy của hacker là một cái máy Calling machine này, sau đó là máy nạn nhân sẽ thông qua máy hacker ở dạng man in the middle, đúng không? Sau đó kết nối với exception rồi ra internet. Thì cái này chúng ta đã nói từ trước đến giờ rồi.
Man in the middle, we can run so many dangerous and effective attacks. So we can spy on all the users, steal their passwords, redirect them to different websites, and this is all just a small taste of what you can do. You'll actually see us build on this in the client-side attacks section, where we're going to completely hack into computers connected to the same network as us. And if you go and do my advanced network hacking course, then you'll see more advanced attacks that'll allow us to do so many cool stuff on the network. And again, all of this is possible because once we connect, we can run ARP spoofing and become the man in the middle. Now in this section, I actually want to show you another method that'll allow us to become the man in the middle. And once we're the man in the middle, we'll be able to run all of the attacks that you've seen so far and all of the other man in the middle attacks that you'll learn in the future. So let's go back to the first diagram that we learned in this course. When we were talking about how networks work in general, we said the only device that has access to the internet is the access point, and whenever a client wants to access something, they send the request to the access point goes to the internet, gets the response and send it back to the client.
Việc kết nối internet bình thường giữa các máy client, tức là máy người dùng bình thường, thì sẽ thông qua cái exception, đúng không? Và cái này đóng vai trò router không dây của wifi đấy, để kết nối với internet. Sau đó là những cái yêu cầu của người dùng gửi đến, ví dụ như là những cái yêu cầu về HTTP gửi đi thì sẽ request và sẽ lấy response trở về, sẽ tải trong web về. Đấy là cách làm thông thường ở cái mạng bình thường.
Now, what if we replace this access point with our hacker computer? So what if we can use our machine to create a Wi-Fi network that actually has internet access, so people will actually try to come in and connect to our network to access the internet, and then when they connect to our network, by default, we will be the man in the middle because we are the router. So we won't really need to exploit anything. We are automatically the man in the middle, and the clients will automatically send us any requests because they want to access the internet, and we will see these requests, obviously, go to the internet, get them what they want, and give it back to them. This way, we'll be able to launch all of the attacks that I showed you previously without the need to exploit the ARP protocol, so without the need to run ARP spoofing. All we'll have to do once our network is running and we have clients connected, we can just start sniffing using Wireshark or using man in the middle F.
Ở đây tác giả nói là tất cả những cái phần trước chúng ta tấn công, không phải chúng ta mà là hacker tấn công ARP spoofing ấy, thì đơn giản là để làm gì? Để biến cái máy của hacker trở thành máy ở giữa, đúng không? Man in the middle, thì nó sẽ sniffing được dữ liệu của các nạn nhân đến internet. Thế bây giờ nếu mà hacker tạo ra một cái wifi mà thực ra đây là một cái máy, ví dụ như chạy cả limousine này, sau đó nó bật cả wifi lên để tạo thành một cái access point qua cái cả wifi đấy, và nó sẽ cho cái mạng này thành mạng miễn phí để người dùng có thể vào được internet. Thì lúc đó thì máy của hacker nó sẽ chính là một cái máy ở giữa, đúng không? Máy middle rồi, cho nên là không cần phải chạy ARP spoofing nữa, cứ thế mà sniffing thôi, bật Wireshark lên là capture được gói tin rồi.
So, for this to work, you need a computer, and we already have our hacker computer with Kali Linux. You also need internet access, and you need a wireless device that's going to broadcast the Wi-Fi signal and tell all the neighboring devices that I am a network, you can come in and connect to me. So, you will need, first of all, an interface that has internet connection. This interface, it can be a Wi-Fi interface connected to the internet, it could be an Ethernet interface connected to an Ethernet network, it could be a 3G or a 4G dongle, and it even can be a virtual interface, and this is what I'm actually going to do. It's going to be my ETH0, the virtual interface that is connected to my NAT network. So this can be any network device as long as it has internet access. The next interface that you will need, like I said, it's gonna have to be a Wi-Fi interface because it needs to be able to broadcast the signal for the network, and you can't use any Wi-Fi interface. This interface needs to be able to act as an access point. So it needs to be capable of acting like a proper access point, like a router. Now, all of the Wi-Fi adapters that I recommend support this mode, and I've already included a video.
Ở đây thì cái máy của hacker này để hoạt động giống như một cái bộ phát Wi-Fi là phải có hai giao diện, nó giống như cái bộ Wi-Fi thật. Thì chúng ta có thấy là nó có một cái giao diện WAN, đúng không? Để kết nối internet. Thì cái giao diện này thì nó có thể đơn giản là một cái kết nối internet bình thường thôi, nó là một cái các mạng LAN, một cái giao diện Wi-Fi cũng được, kết nối internet, hoặc là một cái giao diện 3G, 4G gì đó kết nối với internet, miễn là kết nối được internet qua giao diện này. Còn phía này là một cái card Wi-Fi khác để đóng vai trò là cái card quảng bá. Nó giống như là cái Wi-Fi các bạn nhìn thấy nó có cái anten đây, đúng không? Thì nó sẽ có cái giao diện để nó quảng bá trong mạng không dây với các client. Tất nhiên chúng ta phải có cái software để nó chạy cái phần mềm này để tạo thành Wi-Fi.
In the resources before when I first spoke about wireless adapters, but I'm also going to include this video in the resources of this lecture. So if you're going to buy one, or if you're not sure how to pick the right one, then check out this video. It should be helpful for you. So once we have this set up properly, we can use our computer to start an access point, and it's going to act exactly like a router. So people will be able to see the network when they look for Wi-Fi networks, they'll be able to connect to it and get internet connection. But when they connect, they will have to send us all of their requests because we are the router, we are the access point. So by default, we will be the man in the middle. Therefore, you'll be able to execute all man-in-the-middle attacks that you learned so far and any other man-in-the-middle attacks that you will learn in the future. So basically, ARP spoofing is one method of becoming the man in the middle, and what I'm going to show you right now is another method of becoming the man in the middle. Now, you can see that in order to use our computer as an access point, we need a number of components to be configured properly. So first of all, we need our wireless interface to broadcast the signal as if it's a real network. This will allow other clients to connect to it, but that's not the end of the road. The wireless interface needs to know when these clients are requesting websites. It needs to be able to forward these requests to the other interface that is connected to the internet. Then again, it will need to be able to know when the responses come back and forward all of this to the right client. Now you can configure all of these things manually, and I actually cover this in my advanced network hacking course, and I cover a lot of advanced things that you can do with the fake access point, like launching an evil twin attack, hacking into WPA2 enterprise, and so on. But this would take at least 30 lectures, and this is not a network hacking course. This is a general ethical hacking course. Therefore, that would be out of the scope of this lecture. If you're interested in learning how to do this manually and how to run advanced attacks using the fake access point, then check out my advanced network hacking course in the bonus lecture, the last lecture of this course. For now, for this course, I'm going to show you a great way of quickly creating a fake access point that will allow us to become the man in the middle, similar to what's shown in this diagram. The tool that we're going to use is called Mana Toolkit, and it's basically a set of tools that allow us to automatically create a fake access point, automatically sniff data, bypass HTTPS, and so on. So the tool comes with three main start scripts. So the first one, start now upstream, will allow us to start a fake access point with no internet access.
Cái phần mềm để tạo ra cái fake access point này nó tên là Mana Toolkit. Thì nó có những tính năng như này: tự động cấu hình và tạo ra access point giả mạo này, tự động nghe lén dữ liệu này, tự động bỏ qua HTTPS này, tức là nó sẽ có thể vượt qua được cái giao thức HTTPS, nó tạo ra những cái phiên bản HTTP, đúng không?
Access. So this is not really useful for us, and I will not use this in this lecture. The next one is start not simple. This will start a fake access point with internet access. The third one, start not full, will start a fake access point with internet access, and it will automatically start sniffing data and bypass HTTPS. Now I actually always use start not simple. I never use start not full because this fails a lot of the times, and we already learned how to start sniffing and bypass HTTPS using.
Cái phần mềm này nó có 3 cái kịch bản có thể chạy với những cái file tương ứng. Thì ở đây tác giả lựa chọn cái thứ hai, bởi vì tác giả đã biết, tức là chúng ta đã biết cái cách mà sniffing rồi. Còn cái kịch bản thứ ba này thì cái phần mềm Mana Toolkit này nó sẽ tự động sniffing này, tự động để bypass HTTPS. Nhưng mà chúng ta đã biết ở những cái phần trước, chúng ta đã biết những cái cách này rồi. Sniff data có thể dùng cái gì đó, ví dụ như là soi sát và cái phương pháp để vượt qua HTTPS, chúng ta biết rồi.
Better cap. So you can always start not simple. This will start a fake access point for you with internet access. And then you can open another terminal window, use better cap exactly as I showed you before, and you'll be able to sniff data and bypass HTTPS. You can also use Wireshark if you want to sniff the data and analyze them, again exactly as shown before. Now, before doing anything, I want to show you the network settings of my Kali machine. So I'm going to select it here. I'm going to go to Settings, Network. And as you can see, it's set to use a NAT network. So now if I go to my Kali machine and do ifconfig, we'll see we have an interface called ETH0. This interface is a virtual interface created by VirtualBox because we set this machine to use a NAT network. You can also see that this interface has an IP address, which means that it is properly connected to this NAT network, and it will provide the Kali machine with internet access as long as my host machine right here has internet access. So now on my Kali, if I go and let's say if I just go to bing.com on my browser, you'll see that I can successfully go to the website because Kali is connected to the internet through this virtual interface that is called ETH0. Now, if we go back to our diagram that shows what we need to create an access point, you can see that we need an interface that is connected to the internet. We don't care what type of interface this is, as long as this interface has internet access. So in our example, we're going to be using ETH0 to provide our fake access point with internet access. The other interface that we need, we said that this needs to be a wireless adapter that is able to act as an access point. Again, if I go back to the result of my ifconfig, you can see I already have a wireless adapter connected to this computer. It's called LAN 0. Keep in mind that this is in managed mode. It's not in monitor mode. And it is not connected to anything. So you can see it does not have an IP address. This is very, very important. It needs to be, first of all, in managed mode, and second, not connected to any network. So even if we go at the network manager in here, you can see we have wired connected. This is my ETH0, and Wi-Fi not connected. Once we have everything configured properly, you're ready to use Mana. And before we started, we should modify its settings. Mana's settings are stored in a text file. So to edit the settings, we're going to open this file and edit it using LeafPad, which is just a text editor. So I'm going to type LeafPad, followed by the location of the file that we want to modify. And the settings file for Mana is stored in etc mana toolkit hostapd mana.conf. So all we're doing with this command is we're using a text editor called LeafPad to open a file that is stored in this path. So when we hit enter, you'll see we have the text editor here opening the file for us. And all of these are the settings that you can modify for Mana. You can actually get a full list and a full description of all the settings that you can modify in this link. But we don't need this for now. The main thing that you need to modify is the interface. This is the interface that you want to use to broadcast the signal. So basically it is this component, and in my example, this is going to be LAN 0. This is my wireless interface. So I'm keeping this the same. The next thing that you might want to modify is the SSID. This is the network name that will appear when people look for Wi-Fi networks. I'm going to keep this as internet, so when people look for networks, they will see my fake access point under this name. So I have nothing to save right now, but if you modified anything, make sure you save the file from File, Save, and then close it. And the next file that we'll need to modify is the start script. This is the file that will actually start Mana Toolkit for us. Again, we're going to use LeafPad to open and edit this file. So we're gonna type leafpad followed by the location of Mana's start script, which is in user share Mana toolkit run mana start not simple.sh. Now in this file, there are two main things that you need to modify. The first one is the upstream interface. This is the interface that has internet access. So this is this component right here. And as we've seen before, this is ETH0 in my case. So I'm going to leave this the same. The next one, the PHY, is again the interface that is gonna broadcast the signal. So in my example, this is my wireless adapter and it is called LAN 0, not LAN 1. So I'm actually gonna modify this to LAN 0. Then I'm gonna save it, Control S, and quit it, Control Q. And that's it. We're ready to start the fake access point. And like we said before, we're going to be starting it using this script right here, the start not simple. That's why we modified it. So all we have to do is I'm going to copy this because that's its location. So in order to start it, because this ends with a .sh, we're going to do bash followed by the location of the script. So when we wanted to modify it using a text editor, we used a program called leafpad followed by the path of the file. Right now, we don't want to modify it. We want to execute the code inside it. The code inside it is a bash script code. That's why we're saying I want to run this file using bash. Now I'm gonna hit enter. And as you can see, it's telling me that the access point is enabled and I can press enter to kill the access point, so to exit it. Now, sometimes the first time that you run this script, it will not work. It will actually give you an error. So it's a good idea to actually just run the code again, literally the same command. If it fails, if it complains about a specific error, just run the command again and it might work. If it didn't work for the second time, then ask me in the Q&A section and we will respond to you and help you fix this issue. So now let's go and try to connect to this network and see if it actually works. So right here I have a Windows machine. It's another virtual machine, but I have another wireless adapter connected to this machine. Do not test this from your host machine because the fake access point is getting its internet access from the host machine through the NAT network. So if you test this network from the host machine, the network will not work. So either test it from another virtual machine with another wireless adapter, or if you don't have another wireless adapter, then you can test it from your phone or from another laptop or any other computer within range. But do not ever test it from the host machine. So right here, I'm going to search for networks to connect to. And as you can see, I have a network called Internet. It does not use a password, so I'm just going to connect to it. As you can see, I'm connected now, and I'm going to open Firefox just to check if I have internet connection. So I'm going to go to bing.com. And as you can see, bing.com is loading. So now I actually have internet access. So now anything I do on this computer will have to be sent to the access point. If I want to access any websites, if I enter any passwords and usernames, everything is going to go to the access point. And the access point is the hacker machine. So the hacker machine is already the man in the middle. So now you're at the same position that you would be after running an ARP spoofing attack. So you can go ahead and use Wireshark to sniff packets and analyze them, or you can go and use man in the middle F exactly as I showed you before. The only thing that you need to keep in mind when using Wireshark or Man in the Middle F or any other tool, you need to set the interface to the interface that is broadcasting the signal. So this is the interface that you set in the PHY option, not in the upstream. So in my case right now, this would be LAN 0, not ETH 0. Also, if you're going to use Man in the Middle F, theoretically, you wouldn't need to use the --arp --spoof argument, but I noticed that the tool will not work unless you add that argument, so you can add it in and you'll see that it'll work exactly as shown before.
Việc thiết lập một cái access point giả mạo để có thể làm cái việc để chúng ta để hacker nó có thể tấn công managed vendor rất là dễ dàng. Cho nên là khi mà ra những cái internet công cộng mà chúng ta thấy có vẻ không phải an toàn thì chúng ta cũng không nên là vào trang web đăng nhập, bởi vì rất có thể là các bạn không để ý cái trang đăng nhập nó chuyển hướng sang một cái trang không mã hóa, và lúc đó các bạn cũng mất tài khoản khi chơi. Bây giờ cho điểm danh nhé. Không biết còn bao nhiêu bạn đây? Nghỉ hết rồi. Vân Anh có không nhỉ? Anh Cường.
Ôi em ạ.
Nhật Cường. Đức Duy.
Duy có ạ.
Bà Dương.
Bà Dương có.
Bà Dương có. Văn Đạt.
Dạ có ạ.
Trần Hải.
Có ạ.
Vân Anh có đúng không ạ? Đinh Thị Hào.
Có.
Có bé thế. Khắc Hiếu. Hoàn có đúng không?
Dạ có em ạ.
Anh Hoàng.
Có ạ.
Anh Hoàng có. Công Hoàng.
Có ạ.
Từ đấy nhà thầy copy hay sao? Công Hoàng có nhỉ?
Có ạ.
Cô Hùng.
Hùng có ạ.
Huỳnh Huy.
Có.
Quang Huy.
Có.
Ngô Huy.
Có.
Ngư Huy.
Có.
Đức Khánh.
Có.
Xuân Khánh.
Dạ có ạ.
Duy Minh.
Dạ có.
Phương Mỹ. Mỹ như có mà. Trọng Nghĩa.
Có em ạ. Có em ạ.
Oanh có rồi. Trung Phong. Hồng Phong.
Có em ạ.
Hoài Sơn.
Hoài Sơn có bạn ấy chat ạ.
Xuân Tạo.
Có em ạ.
Minh Tâm.
Có ạ.
Văn Thành.
Dạ có.
Quốc Thắng. Trần Quốc Thắng.
Có.
Trung Thông.
Có ạ.
Anh Thư.
Có.
Công Trịnh.
Có.
Trưởng có rồi.
Có.
Anh Tuấn.
Có ạ.
Tùng.
Có em ạ.
Duy Tuyền. Rồi, ok. Và kết thúc hôm nay. Buổi sau chúng ta sẽ nói sang về tấn công đốt và đi đốt. Chào các em nhé.